We've got a curve, and in part A, we're asked, does it go through the origin? Well, the first reason why I can say it does not is if you compare our equation here with the equation of a circle, centre the origin and radius r, its equation is x squared plus y squared is equal to r squared. And as I say, that is a circle centre the origin, but it has a radius. And if we equate r squared to 16, I can also say this circle has a radius of 4. So no, it does not go through the origin. The other way to prove it is to say, well, the origin is at the coordinates of 0, 0. And that is where x equals 0 and y equals 0. And if this line, this curve, passes through this point, this should be a solution that works in the equation. And if I sub x equals 0, y equals 0 in here, I get 0 squared plus 0 squared is equal to 16. It's not equal to 16. So I can say no, that x squared plus y squared is equal to 16 does not go through the origin. Now, for part B, it's again not strictly necessary to have recognised that our curve here is in fact a circle. And I've told you it's a circle radius 4 because the radius is the square root of 16, which is 4. So this circle is of radius 4. So this coordinate point is 4, 0, and this coordinate point is negative 4, 0. So those are in fact the answers. But let's find it if you didn't know that this was a circle. Well, find the values of x where it intersects the x-axis. So what's special about the intersections with the x-axis? Well, what's special is that y is equal to 0. So if we sub y equals 0 into our equation, which is x squared, well, if y is 0, we get x squared is equal to 16. And if we take the square root, we get that x is equal to plus or minus the square root of 16. Or x is equal to plus or minus 4. Always plus or minus, except when you know you can reject the minus answer because let's say you're looking at the length of a triangle and that length cannot be negative. But coordinates can be negative. So that is in fact the answer and confirms our two coordinates in the diagram.